Hi, my name is Haley Thompson, and my proposed experiment is a silica gel-supported oxidative cleavage of alkynes using a ruthenium tetroxide catalyst. So for my experiment, I'm going to be synthesizing a carboxylic acid from an alkyne, and I'm going to be using phenylacetylene derivatives and green reagents to do this. And my catalyst is going to be a ruthenium tetroxide, which is really good at oxidative cleavage and is used in industry and academia to produce different chemicals for intermediate reactions. So green chemistry is one of the main concepts of my proposal. Green chemistry is a fairly new concept. It was developed from the realization that there are holes in the ozone layer and the alarm over the pollution of Earth. It reduces hazardous chemicals and waste that are produced in chemical reactions, and a reaction can be made green through several different methods. Some of the most common are going to be a shorter synthesis time, using catalytic reagents, and using less harmful solvents. And I am going to be doing all of these in my experiment. So the media that I'm going to be using is silica gel, which is a heterogeneous media. And heterogeneous reagents offer a lot of additional benefits that a homogeneous counterpart does not. The procedures that involve heterogeneous reagents, they involve minimum handling of your reagents and often produce enhanced reaction rates and generate smaller amounts of waste, which is part of what makes this reaction a green reaction. And they also make your product isolation easier. So silica gel is the one I've chosen, and it's great because it's very porous, it's non-toxic, and it will not react with the chemicals that you're using in your reaction. And it is used most commonly in column chromatography, and it essentially works by anchoring the molecules to its surface so they cannot be absorbed into the atmosphere. And in my experiment, it will be used to catch my catalyst. So my chosen catalyst is ruthenium tetroxide, which was introduced by Drassi and Engel in the early 1950s. And now it has become a very commonly used and versatile catalyst. It is mostly used for an oxidizing reagent, and it is also very expensive. So what I have proposed to do for my experiment to cut down on costs is to generate it from ruthenium trichloride and a less expensive co-oxidant. My procedure is good for an undergraduate student. It is ideal because it is simple and it is quick. There are not a lot of steps in the synthesis. The first step is obviously going to be preparing my catalyst, so I will be using ruthenium trichloride and periodic acid, which is the co-oxidant that I have chosen. And once you synthesize your catalyst, you add it to the silica gel and the solvent. And the solvent that I have chosen for my experiment is DMC. Next, you'll add in your starting material, which is going to be my alkyne. And for this experiment, I have chosen to use phenylacetylene derivatives. So I will be using 6 different types, and you'll see in the next slide what those are going to be. And then you let your reaction go, and you monitor it by thin layer chromatography. And once it is completed, you will evaporate your solvent and be left with your product. So this is just a generic reaction for my experiment using the phenylacetylene and the periodic acid, ruthenium trichloride, to make your catalyst. and then it should synthesize benzoic acid in this case, or just some kind of carboxylic acid. The total cost of my materials that I need for this are going to be about $1,200, which is, I think, within an acceptable range for an undergraduate researcher, especially considering that at SEMO we already have several of these products, such as the silica gel and the periodic acid. The most expensive thing is obviously going to be the ruthenium trichloride, which is about $270, but everything else compared to that is relatively inexpensive. And these are the 6 phenylacetylene derivatives that I have chosen, one being phenylacetylene itself. If the experiment goes to completion and works well, I have discussed using more in the future. So since this is a green reaction, there are no particularly dangerous chemicals that I'm going to be working with. So standard lab safety procedures is all that I really need to follow. There's no precautions like specific to this experiment that I need to take. So I will just be taking the normal precautions, such as the lab coat, goggles, knowing where the fire extinguisher is located, things like that. These are all the references that I used in my research, and that is all. Thank you.